Welcome to part 2 of Omni Calculator's mini-series on how to cool your drinks faster with science. If you haven't watched the first part, you will still be able to follow everything, but it might be a little bit more hard to understand certain things. So do yourself a favor and subscribe to the channel and hit the notification bell so you don't miss any more videos. Now, let's get hacking. Most of the cooling hacks that you find online assume that you already have all the supplies and you just want your drinks to be cooled faster. However, they say prevention is the best medicine, so is there something we could do during the preparation phase? If you remember the 3 pillars of cooling from the first video, heat transfer is determined by the material in which the drink is stored. So by avoiding glass and going for metal, we should give ourselves a great advantage in theory. But in science, theory is nothing without experimental results, so we gotta test it. What we have here are 2 containers of definitely not beer. The shape, volume, and liquid are as similar as possible, with the main difference being that one is made out of metal and the other is glass. Their temperature is also the same, equal to the temperature in the room. So now I just put them in the freezer and wait. In the meantime, let's calculate what we expect to see in our experiment. Using the free calculator that I built, you can see how a glass bottle should get to around 9 degrees Celsius in about an hour, whilst a can of definitely not beer should go even below 0 in the same amount of time. In case you're wondering, the reason there is no option for definitely not beer in the calculator is that I measure the physical properties of it and they are very closely related to actual beer. Shocking, right? Now we just need to check how close our simulations and the reality actually are. And so 1 hour has passed already and it is time to open the drinks and see how much the temperature has changed. So we have our thermometer going into the drink and waiting for the temperature to stabilize. Same with the other can, and now we wait. Let's change the thermometers to make sure that the measurements are right. And we can see here that if we do the average between the 2 measurements from each thermometer, we would see that the metal can is much colder. So yeah, I mixed up the numbers and the glass bottle was actually colder than the metal can. Doesn't make sense because our simulations show the opposite. So I got thinking and I realized that we're cooling very slowly in the freezer. So there are other factors that can play a role. I didn't measure the initial
temperature of the liquid. There could be positioning issues inside the freezer. There could be convection issues.
So I decided to remove any of these factors by just cranking it up to 11. Since cooling down a drink and warming it up are exactly the same processes, just in a different direction, what I did is I took both containers and I placed them inside of boiling water. As you can see, the metal can warms up way faster than the glass bottle, which is what we expected because metal is a heat conductor and glass is an insulator. And that's our final answer. It took us way more effort than I was expecting. But what can you do? Sometimes science is just a bitch. So there you have it. If you can buy a can, say pass to glass, and somewhere in the middle we would have plastic as the most practical. The best thing about this hack is that it can work in combination with any of the other hacks we are going to try. So if you enjoyed the video, hit the like button, subscribe to the channel if you want to see how salt can cool water down or not. Until then, have a nice day. Bye!